Hey, welcome everyone. This is our Boston.NET architecture group. We're meeting on June 18th, 2025. And our topic tonight is, has AI removed the need for software architects? And this topic tonight is a little bit of presentation. We'll go through, a little bit about what AI is, what do we mean by that. I have several slides, but I'll go through pretty quickly and then dive into some interesting things that I've seen lately come up in my feeds on LinkedIn and yeah, just related to this topic. So should be interesting as we dive in here tonight. So just a little bit about who I am. I was just mentioning a moment ago, I've started a new position at Torion, which is a Belgian company. I'm a principal product security architect, as well as threat modeling trainer. I'm doing, mostly software consulting, or sorry, security consulting, really focused on application security and threat modeling, which I've been doing for a number of years. But of course, also for many, many years, I was a software developer, architect, building out lots and lots of solutions. I'm a Microsoft MVP, have been really since this most recent phase, since 2015. But focused on developer security, Visual Studio technologies. I'm certified software security lifecycle professional from ISC Squared. Number of years, also co-host with Chris Romeo. Been doing that now for 9 years. We're actually starting our 9th year with the season. We just started a podcast this week. We delivered. And then also co-organizer for the Boston Code Camp. Been doing that for a number of years. And then a meetup leader for a couple of groups. One here, of course, this one, Boston.NET Architecture Group, which has been around since late rather, 2003 and early 2004, so for over 20 years. And then also I lead the Amherst Security Group. If you'd like to reach out, I'm on LinkedIn and a few other places. Our last AI talk that we had for our group was actually in June 2023. Rich Crane came and spoke to us about exploring the power of generative AI and LLMs. Great talk. That was a hybrid meeting, and we do have a video of that recording. It was a fun thing to do because we were right there in the room and trying to capture it as well as get the slides and everything. And so if you'd like to go back and check that out, welcome to do so. Now, of course, as I mentioned with our Boston Code Camp, we've had a number of sessions over the years, past several sessions where the majority of the talks were related to AI. So I'm not going to go over all of those tonight. I will give a really quick, brief intro to what AI is and what does it mean and all that stuff. But we're going to dive in really to our main topic here tonight, and how AI as a tool for software architects, for developers, can be useful, but there may be some drawbacks as well. And that's some of the things we'll talk about. So just to, again, dive in, AI, we say it a lot, AI, 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 what does that mean? Of course, it's really representing artificial intelligence, but we've used this so much now, it's sort of disintegrated, as it says, soggy tissue into phonetic nothingness. And this came from 2019. I think it's still is valid, that AI is everywhere, and even more so, I think, even in the last few years that I've been working with teams building AI projects. Of course, my focus is on security, but thinking about how does AI integrate into the things that we're doing. It's, again, just all over the place. Google's definition: ability of a computer program or machine to think and learn. Also, field of study which tries to make computers smart. And that learning part, it's really interesting. We'll talk a bit about that tonight, I think. Machine learning, type of artificial intelligence, or AI, providing computers with the ability to learn without being explicitly programmed. Data analysis, process of inspecting, cleansing, transforming, and modeling data. And that's a lot of what's going on behind the covers to get to where we can use those models that are created. Now, AI plus ML, as we said, machine learning is a branch of artificial intelligence concerned with design and development of algorithms that help computers to evolve behaviors based on empirical data. And as intelligence requires knowledge, it's necessary for the computers to acquire knowledge, of course. And that means data, lots of data. Not this kind of data. Uh, this could also date us if people don't know who that is, but it's a good example of AI, though, data from Star Trek Next Generation. So learning system model, typically just at a very high level, an overview of what you're doing is you have input samples, data from all kinds of places. It could be you basically use those samples, that data, to train the system. You also take a part of that data and use it as a testing set of data for verifying that when you've trained the system, that you're getting the model that you're creating and it makes sense. And so you're using the data to say, okay, this is what we think it does or how it works, and then verify it using the data, some of the sample of the data as testing data to validate the model, how you see things happening or patterns and so forth at a high level. Now, training is that process of making the system able to learn. Training set and testing set, as I mentioned, comes from the same distribution. And sometimes you will need to make some assumptions or bias based on, again, the data, where did it come from? Is it of one kind more than another? And so on, may automatically or inherently give certain assumptions or bias because of the fact you're not collecting all data or some certain kinds of data over another. And of course, several factors affecting performance, the types of training provided, uh, any initial background knowledge, type of feedback, learning algorithms used, and so on. Of course, what we're using are algorithms, and the success of machine learning system also depends on those algorithms. They control search to find and build knowledge structures, and those learning algorithms should extract useful information from training examples. Now, there are typically a few different kinds of algorithms. One are related to supervised learning, prediction, classification, regression, unsupervised learning, related to clustering, probability distribution estimation. You'll find typically supervised learning is where you do know the data much better. You have a lot of control over it. Unsupervised learning typically is around the sense that you don't have, maybe you have lots and lots of data. You don't have a good way of classifying that data with labeling. And so you do rely more on probability distribution and finding those associations to try to evaluate, does this thing really match or go with this other thing? And the larger the model and the collection of data to create that model, you'll typically are leaning more towards unsupervised learning, and that's essentially what an LLM is. Actually, it's really using that algorithm versus supervised, mainly because of the tremendous amount of data that you need to create it. Now, this is just a couple of, or one rather. I got a couple of these here just to show you at a graphical way of supervised learning versus unsupervised learning. And so, if you notice, again, the training text documents, generating some features and vectors, basically understanding how to divide, let's say, text, maybe words that are one syllable, two syllable, three syllables, and divide those up and then figure out how they go together and then inputting that into your machine learning algorithm, which then helps you create your predictive model. Now, as I said, supervised learning, one difference here is that we have labels. We really understand the data itself, we've labeled it well, and so at the end there you get an expected label. The difference for unsupervised learning is, if you notice, there are no labels. And so here we have lots and lots of data, typically training text, documents, images, sounds, again doing breaking that out into your features and vectors, applying your algorithm, getting a model. But the result, though, is more, instead of the expected label, you're getting a likelihood or cluster ID or better representation. So it's probabilistic. You're not exactly always going to get the most perfect match. You'll get better and better at it for, certainly with more training, or more data rather, and training, but there's always going to be that opportunity to miss or to not get it right. And that's something that we see quite often in LLMs. If you ever noticed hallucinations, we'll talk about that a little bit later as well, where some things, it's making predictions about what's the next thing that matches what you're looking for, and it gets it wrong because when it tried to match things, it didn't quite get it right. And so that's how that happens, and why it can happen is mainly because just a large amount of data that it's having to try to figure out those relationships between parts of those data to each other. Now, generative AI, broad field, encompassing AI models, create new content, while LLMs, or large language models, are specific type of generative AI. I will say, give you a disclaimer, all the other slides before this were mine. I've used those before for years for my security work. A number of these are actually from generative AI. So if they look like they came from an AI, they did. So I want to make sure that's clear. But anyway, essentially all LLMs are generative AI, but not all generative AI is an LLM. So what's an LLM? Large language model. It's essentially related to text data. So it's been trained on vast amounts of text data to understand and generate human language. And again, typically using unsupervised learning. They can perform various tasks like text summarization, translation, code generation, and more, and essentially sophisticated language predictors capable of producing coherent and contextually relevant text based on prompts. A lot of core concepts here, but some of the ones I'll really point out here is that for LLMs, again, there's deep learning architectures, there's a transformer model, there's training data, lots of it. Parameters are really, that's one of the things that sometimes as a developer, we think about parameters. What does that mean in relation to AI? It's not about parameters to, let's say, a method call, but instead, all the relationships, the words and the phrases that are broken down so that can help the model be able to understand the data. And then you can also have multimodality, which means it's not just text, but you could also potentially have various layers of other types of data, for example, images. The foundation model really is the heart of an LLM. And if you notice there, there's this idea of the black box, in the sense that we don't understand everything that's happening in there. We understand a lot of what's going on as far as where the data came from. Maybe it's the internet, maybe it's other places collected. We get the resulting model, but all the work that's inside the foundation model itself, much of that can be very proprietary because it's so large. So think of the companies that are holding large models now and providing generative AI or ways of connecting and interacting with these LLMs. We don't know all that's going on there. A lot of that's proprietary, and so very interesting to note about how they work or how they are set up. Now, some key capabilities of an LLM: text generation, human-like text, articles, stories, code, and so on. They seem to be able to, which is great, understand language, interpret human language, which enables tasks like translation, summarization, and questions answering. There's a natural language processing. So powering applications like chatbots, virtual assistants, sentiment analysis tools, and as I mentioned, some typical examples, ChatGPT, Claude, Microsoft with Copilot, Gemini from Google, and Meta AI LLMs as well, and many other examples. These are just a few that are well known. LLMs help developers as well. We see this quite a bit lately, is code completion and generation that can predict and suggest code as developers type, can accelerate the coding process, reduce errors. They can explain code and help document that code. They can help you with debugging and error handling, and also with code reviews, taking a look at code and evaluating and pointing out potential issues, various code smells, security vulnerabilities, and so on. Helping software architects. Absolutely, LLMs can recommend relevant design patterns based on project requirements that can help with design. So, for example, breaking down complex problems into smaller manageable components and suggest system boundaries and responsibilities. Architecture design, decision modeling rather, can help generate documentation, diagrams. They can certainly optimize your performance. So all kinds of great things that they can do. But what are some of the challenges and concerns? We mentioned this earlier just briefly, but hallucinations and errors. They can sometimes generate inaccurate or misleading information. Crucial to validate outputs and use them as a starting point rather than a definitive answer. They can be very costly, resource intensive, requiring significant computing power and infrastructure. And for that very reason alone, many organizations don't necessarily run a large LLM. There are certainly some options and opportunities for smaller LLMs, and I've seen some interesting information about that lately. But the other thing that's also of interest as well, in terms of a challenge as well as concern, is that ethics related to potential bias, job displacement, and responsible use of AI in software development. So those are certainly things that have come up. I've seen that in terms of, um, for hiring developers who are using AI to perhaps try to ace an interview by answering questions and just using, a GPT that's answering for them or helping them answer the questions and so on. So those kinds of things, certainly of concern, as well as the code that you're writing and is it yours? Is it really the GPT? How do we handle that and so on? All right, so a little bit of demo time, and then I'm going to kind of break out into some questions, or a couple of things I wanted to look at tonight. This is I have a couple examples here. This is ChatGPT. I believe it's using 4.0 Mini. And what I did today, I just said, design me a .NET web application. And so I went through and said, I need a little bit more context. What's the purpose? Do you want to use .NET Core? And it recommended .NET 8. And then what front end, what features. Once you answer these, I can generate a complete structure for your .NET web application, including project setup and so on and so on. And so I said, I want a blog. I said, no, I don't want .NET 8. I want 9 because I know that's actually the latest one or one of the latest ones. And there's a caveat to that. You probably already know. Razor pages, so why not? And then go ahead and add some authentication login register. And so it said, hey, great. Here's your starter application, .NET 9, Razor pages, authentication, so on. And so it gave a project structure. It gave some things, step by step, some models, configuring EF core and identity, and some code related to that, enabling identity UI, and then some other features. And let's see. Yes, do you want us to build the Razor pages? I said, sure, yes, let's do it. And so it gave me some of that code, some page views, blog post page, and so on and so on. Now, one thing I didn't do, I will admit, I didn't pull all that out and put it into a solution and see if I could compile it and get it to work. My main thing here was I just wanted to see, as an architect, we're developer, but let's think of it as an architect. How could I use this to at least get a start and a design of a system? And potentially, are there any patterns that I need to think about, or any trade-offs that I need to think about? And one of them I had thought about was, why did you recommend uh, .NET 8 over 9? And I already knew this, but it came back with what I already knew, which was great. 8 is long-term support, and so that will the support will be there for 3 years until November 2026. 9 is what's considered standard term support, and it's current, but also until mid 2026. I said, well, what's the difference? Well, again, in terms of time, in terms of making decisions, you may decide that, well, 9's the latest, let's go with that. And then 10's right after that, shipping out later this year. We can make a decision, or we can say, let's stay with 8 because of the fact typically those are well proven, and we already know that it's going to give us the longest amount of time for support, a little bit longer than 9. However, again, it's so it gave us a recommendation. But one thing that's interesting as an architect, when you're looking at this and you're making decisions, and they gave us some other things here as well, as why it picked one over the other, or use one or the other for what you're trying to decide. It's still not necessarily thinking about or telling me some of these things that I just mentioned. I can look at this and make a decision based on the information, but again, it's not necessarily saying, well, by the way, maybe you should just go ahead and consider 9 because that'll easily upgrade to 10 when that's ready. Give it a couple months and wait, or actually this starting now. So by next year, you'll already have that. And so those again are some things that you as an architect may make some decisions about, where this gives you certainly some information, but is it enough if you don't have that background, if you don't have that experience, if you're coming at this for the first time and don't realize how this works for long-term support versus standard term support, and all of those things that are happening back and forth in terms of dates, and if I ship a product and I lose support, what happens then, and so on. So those are some interesting things to consider and think about, that it may not give you all those answers. Looking at Gemini from Google, looks like this is a 2.5 Flash, asks the same question. And here I got some answers back, excuse me. A little bit more detailed in terms of some options. It actually said, here's a suggested language. The other one didn't mention that. I don't believe, even though all of that, looked to me like it was C#, so that was interesting. And some databases. The other did not ask me about that necessarily. I think it assumed SQLite. and a few other things here that Gemini is doing slightly differently. But it's in some ways it's giving a little bit more detail, technical detail than the GPT was giving me. Now this could also be related to support. I'm using on the GPT. I'm using the again the free version, just what 4.0 or 4.0, sorry, 4.0 mini. And Gemini, I'm using my Google account, which may give me a little bit more access. Not really sure, but just interesting the differences. Project structure. Actually, this was really interesting. Security best practices, very important, of course, as an architect. And I didn't say I was an architect here. Notice that. One thing I didn't indicate at the beginning on either one, I'm an architect. Give me something that would be helpful for me as an architect. I simply said, instead of give me the code for it, design it for me. So that was a little bit of being uh, careful about my wording, but not necessarily saying it as an architect, as I might do in a typical prompt or an example prompt. I did the same thing here. It asked me, what do you want to do? I said a blog, general public. It gave a few more things there. I said 9 as well, hundreds of users. It asked me about that. Now, what's expected scale? And I did say C#. I did say React in this case instead of Razor. I said my budget is mid-level, whatever that means. But some interesting other questions that are also getting closer to what maybe me as an architect might be concerned about. For example, scaling and the particular technologies that I'm using that maybe the other didn't necessarily ask me about. It made some assumptions, I think, and so on. And so again, gave me some code, some suggestions, and a few other things, uh, and so on. And if you're interested, I know I can share these. I believe I can share these links as well, so you can take a look at what it came up, or you just generate your own with the same prompts and see what it comes up with in your own particular favorite GPT that you might be using or LLM that you're using. So some interesting things. But again, as an architect, you're looking at this. I mean, there's a lot more information here for sure, and things to think about. But what about some of these, databases, indexing, and various trade-offs, caching, in-memory, distributed caching? Great that it's given me a lot of these options, but what do those mean? Now, I can certainly ask it, well, that's great at the high level. You're giving me some options here and sort of what they are for each of these, but I still don't know if I'm a new architect. I don't know necessarily what's the best or what are the other trade-offs. You really haven't covered all of those necessarily. And so again, thinking as an architect and looking at this as an architect, this is great and it helps out, but you still need to make some decisions. And so you can certainly build some things, but ultimately you may need to apply some experience and understanding to be able to get to, a good product or what fits for your particular environment that may not necessarily match everything that they provide here. Now, you can certainly get better at prompting. I know that certainly over the last couple of years or so, we've been talking quite a bit about getting better at prompting, prompt engineering. But is that all that you need with this tool to use it effectively as an architect, as a developer? Is just getting better and better at your prompts. And there's been some interesting things that have been coming out recently that have said, no, it's not just a better prompt necessarily that is improving the results, but something that we might need to consider outside of that. So we'll come back to some of these things here in a moment, but I wanted to continue on to our main part of our talk tonight. I mentioned this in the description for the session tonight, is that Avram Puko had a couple of articles that were published out on InfoQ most recently, and I was taking a look at those. And what struck me again is, he's the head of strategic planning and product architecture at Toga Networks. And what struck me was the fact that, he's very much in support of using AI, which he should be, everybody should be. But how a software architect uses AI in the daily work that he does, as well as this podcast, Dissecting the Intelligence of AI. And I listened to the podcast. I thought it was very good. I read the article, which really is just a summary of some presentations he did. If you're interested and want to take some more time, these are pretty quick to get through on your own if you want to look at it. And we have some summaries of these. But I would highly recommend to go watch his talk on AI as assistant to the software architect. He goes in a lot more detail than I'm going to tonight in terms of the history of AI. What does it mean? The Turing test, we didn't talk about that, but he gives more details about that in terms of applying the Turing test, maybe even the opposite. Is it human? Does it sound too good to be human, for example, in results that you might get from AI? But anyway, just very interesting, and I welcome you to go take a look at it. But some of the key takeaways from those two first resources that were mentioned there, first of all, is that architects will not be replaced by generative AI or LLMs. And I want to open that up. What are your thoughts? And this is an opportunity for discussion tonight. What are your thoughts? Do you think that architects will or will not be replaced by generative AI or LLMs? Anyone?
My impression is it's not on the horizon, but years down, once we get this a little bit better, perhaps. I mean, realistically, all these things are is probabilistic models, and a lot of what we do is that sort of determination, right? Which is going to work, which is more probable to work for this situation.
Right.
Those are my impressions.
Okay, thanks, Phil.
I think it's like the same for developers, will be replaced in some places partially. Like, for example, if you have a small company and you need to do some small project, maybe it will be cheaper for you to check with AI, and maybe it will be not the best solution. But in some cases, I think not for big company, but small companies and with limited resources, you don't need to hire. You need maybe it'll be a better solution, but I believe many businessmen will use generative UI instead of. So will not be replaced, but will be replaced partially, like less. So in general, we'll need less persons. I think so.
Yeah, and I think we're seeing that very early on. We talked about some, and I won't mention them in the recording, but some organizations that are saying we are letting folks go. We're cutting our staff, reducing our staff because of AI, because we are looking to find ways that AI will help us with work that we're doing, certainly faster work, being able to make some comparisons and do some things that maybe 5 people it took this long, and maybe one AI and one person could take be a little faster than that, or something like that. So yeah, we are starting to see that, or at least predictions of that, or even promises, if you will, from organizations saying that, we will be reducing our workforce in the future.
Rob, I kind of wonder if this will actually hurt maybe the less experienced developers rather than the senior people, because the AI can do all that grunt starting stuff, and then a knowledgeable developer would come in and say, okay, what's right about it, what's wrong about it, how do I build this out further? And that might require better skill set than the more junior mid-level people. So I wonder if there might be a bias where your AI becomes your junior mid-level people, and then your senior people just kind of take over after they specify. That's the other thing, specify properly the starting point, because this AI isn't going to just do anything on its own. It's got to be, told, like, what do you need? And so it would sound like a senior person who knows what the hell they're doing would explain, I need, all these different pieces. All right, go build it for me, and then let me go see what you just created.
Hmm.
That would be the hope anyway.
Right. Right.
Let
But
me
that's
add
going to suck for
more,
the younger
maybe,
people.
sorry.
Sorry,
Let
Matt.
me add a couple cents. There is another perspective. Why would you hire senior people if you could hire like middle level, or maybe senior but not architect level people who will talk to AI? AI doesn't provide you like completely wrong answers for architecture. And for, I don't know, 90% of the business, they don't need rocket science. They need just standard, I don't know, CRUD applications. Therefore, I don't know, you can just hire middle level developer who will talk to AI, figure out maybe some guidance, and do the job.
Yeah, a lot of possibilities here, right? Let me go into the next one here, and Evrim's other key takeaway is that they will need to learn how to use these tools, and that architects, his prediction, will be replaced by software architects who know how to leverage generative AI and LLM. So, taken as a whole, these three, you need to know it. If you've been on the fence about it, if you say, I don't need to know this, or that somebody else can handle that. I'm over here doing just fine by myself with this without AI. Reality is, you will need to confront this. You will need to understand it's another tool, as many other tools we've learned over the years, another tool to be aware of, to use, to get familiar with how it works, the ins, the outs, the limitations, and so on. So those are all together some of the things that he mentions, and I think you hit on several of you hit on it. For developers, and depending on those who know how to use the tools, how to interpret the tools, but there's something else that I think that we may be missing. If it's, let's say, for example, it's much cheaper to have junior developers do all of this and just run the AI tools. But do they understand how to interpret? Do they understand how to figure out what's wrong and what's correct and make decisions? Again, some of the things that it helps you with, of course, to be more productive, more effective. They're impressive, but they lack real-world experience, intuition, and ability to make context-aware decisions that human architects possess. So I think that's one of the key things, and what I was kind of pointing out in the demos is that it may give you all these facts. It told you .NET and .8 sorry, 8 and 9, and what's the difference between those? But do we understand that just reading that? Do you have good intuition about it? And if you ask the LLM, what's your intuition? What do you think? It can make a judgment of some sort, but does it know? Does it really understand all the trade-offs? And to be able to make those context-aware decisions. And then that deeper understanding, creative problem solving, and ability to follow up that humans have. Now, are they getting better at this? And I'll open that in everybody's experiences. Are you seeing it getting better, or is this still the case? And this came out a couple months ago, really, 2 or 3 months ago, that this was a summary. And then his talk at one of the conferences was last fall. Is this still true, that LLMs lack that deeper understanding, creative problem solving, and ability to follow up? What are your thoughts and experiences on this? Or the jury's still out and you're still trying to
At
figure that
least,
out?
well, last month I asked multiple questions, ChatGPT, for example, in different areas. For example, I needed to check how to communicate with my neighbors because we switched on sound at 5 a.m. So I needed to ask what is better, like to go to him or to to do something, because for me it's not every day, so it was not, and in answers was very good. So, and when I just try to do this using these prompts from ChatGPT, it was very effective. So it's not like understanding, but it seems like my impression was like a smart person who can advise. So whether was my impression. Maybe it's not for everybody, and in software development, it's more, of course, it's more complicated thing, but in some areas of our life, it's very useful. And I don't know, maybe on this, it seems like you discuss some ideas with human sometimes.
Yeah, absolutely. No, great points. Another aspect of this is that architects bring personal experiences, emotions, and understanding of trade-offs to their work in a way that LLMs cannot. And I think the other thing here is the personal experiences and emotions. You know, what makes us human versus an LLM is that collection of personal experiences and the emotions that go with them. I've been on projects that were extremely successful. I've been on projects that didn't go as well, and we had failures, and we messed up, and we had to back up and fix things and learn from those mistakes. And you certainly have emotions related to that. If you learn something the hard way, as they say, you remember it very well. And it becomes a part of helping you years later, kind of collectively making decisions based on, oh, I remember doing that and this is what happened, or we used that method and it didn't work, or that pattern and it worked great there, but I don't think it'll work great here, even though, you know, the LLM says this is a great pattern, you should be considering it, but I've already done that here and it didn't work. What do you mean? And so on. And so that's something about what we bring to this that an LLM really can't. Any thoughts on that?
Well,
Yeah, go ahead, please.
I was gonna say, you know, it's based on the training. So the things that it's seen it might think, wow, you know, it worked great over here, and it doesn't understand fully the context of, well, why did it work well over there, or why might it not work well in your situation? And that's where, like you say, the experience comes into play, because it only knows this works,
Mhm.
but doesn't actually may know why or
Right.
in what situations.
Right.
I'm sorry, I cut someone off.
It's okay. You also can fix it. I don't know, LLM response by prompting. You can, after first response from LLM, you can ask, are you seeing any downsides or like some maybe problems, future problems with this or that solution? And it will provide you some guidance on this too. So I don't know. Like you can get this experience from LLM too. Maybe it won't be like the best experience, but
Mm.
how can you trust that it will be the best experience from your architecture? You don't know. It's like
Right.
neither.
Right. Right. No, and I wondered about that too, in terms of, yeah, the prompts, like it's the prompt engineering, and maybe just get a better prompts. We'll look at that in a moment too, but let's hold on to that for a moment.
There was
Anyone else?
I was thinking in the same lines with Max too, and the large language model may have more patterns in it than you have experienced in your career too. So there's and then I'm just finishing reading Talking with Strangers by and it talks about how with judge court cases that computers are doing a better job than the judges as far as predicting who to sentence, and it came down to humans default that people are telling the truth and make reasons why they are, and where that's just part of the human. So there's some other sides to it as for where tools and computers can help balance that bias. And
Interesting. So it could widen your, like it may point out biases that you have as a human. Then is what I'm hearing.
right. Yep.
Okay. Interesting.
They talked about also the CIA, like how did I not know that guy's a spy? And I had all these things as I go back in the memory, like that didn't make sense, but I filled in something to make sense of that conversation I had, and things like that that humans do, and I'm not sure. So they could also probably miss things too that humans do too. So
Oh, absolutely.
Yeah.
Absolutely. No, it's great points.
I think
Go ahead.
sorry. Yeah.
No, please.
Thank you. So I think the main concern here is communication between. So if you're an architect, you understand what is a question do we need to ask, because for example AI will not. So for example, you're a business guy, you need to do something, but you cannot even understand how it's possible to implement, because you don't know anything about software. You know how to press buttons, you know something, but you don't know details, and you don't know is the answer correct or not, because you have an answer about, okay, let's use .NET version 8, but you are not sure what is .NET. So that is, at least we need to have a person who can ask correct questions and interpret the answers for hours, because sometimes it's like communication between knowledge of AI and who can do something, because AI will just answers question, but AI will not ask questions, but you need to generate questions about what about anything. So maybe that is the role of new architect.
Yeah, no, it's good points.
It is a good brainstorming tool, though. I don't know if people have used that just to get unstuck, and I use it a lot for that also.
Yeah, and I'm not saying and we already go back to the previous slide, right? It says use the tool. So there are ways that you can use it to be effective, and there's a summary slide. I'll get to that here shortly, that Evram put together in his talk last year. I thought was really good about what the LLMs do for you and what you as an architect need to consider. But no, that's a great point, that it can be a great brainstorming tool. And I think the other thing that's interesting, at least initially, for myself and others, I think we started to use it first as like another Google search or Bing search or something like that. Just search for things, and that's how I initially used it to help with some other work I was doing. Just go search for something, go find something. But then I would look at resources and like, wait a minute, that doesn't even exist. What is that? It's pointing to something, some reference, and I try to find it doing a regular search, and I couldn't find it at all. Like, what is that? Now that's been a while, but um, initially many people use it that way. It's just a search. Partly how you use search for sort of brainstorming, but a little bit more than that. But I think you're right. It's that back and forth, but also verifying, validating as well. But it can help you get unstuck sometimes in terms of ideas. And this actually, yeah, this kind of relates to that. Architects should experiment with LLMs, but not blindly trust their outputs. And so, yeah, experimenting, see what it comes back with. Does that match what you understand? Or maybe it's expanded your understanding. But ultimately, don't blindly trust the outputs. Go check, go verify, and then critically evaluate proposals generated, understand the context, and apply your own judgment and expertise. And so, can you learn? Can you increase your expertise and understanding by using LLMs? I think, yes, to a point you can. But remember, it's only as good as the data that it's based on, which is potentially a lot of bad data too, just like anything else. I think we've already learned, at least many of us, when we go to a search engine, Bing or Google, whatever, and we look for something, most of us, I think, have figured out that the things that are at the very top, the very, very top, may actually be paid content, may be there because of certainly popularity, various reasons why it became popular. But some, at least I know for myself, I usually still go down the page and see if there are any other references that I might want to look at that maybe might give a little bit more information than the very top one. But I look at everything. I want to make sure I understand every reference and not just pick the top one and I'm done if I'm doing any kind of research using a search engine. And so those are looking at it critically and applying judgment and expertise. And I think the similar way with LLMs. They give you a lot of great information, and sometimes it can almost be overwhelming. You saw what Gemini gave me. Design a .NET application, and it gave me pages and pages of information before I even told it what kind of application is it, what language is it, what's the scale that I want to. It gave me lots and lots of options and lots of information that I needed to go parse before I could even ask the next question to be a little bit more clear in what I was looking for. So that can certainly add to our time, but could also, I think, could teach us or help us with our expertise as well. So just to kind of take a slight detour for a moment, and then we'll wrap up tonight. This is a paper that just came out. Anybody heard about this one? Is this familiar? The Illusion of Thinking from Apple. This was published early June of this month. Understanding the strengths and limitations of reasoning models via the lens of problem complexity. Basically, what the paper indicates is that they did a lot of tests with some LLMs and determined that as the problem became more complex, the prompts or whatever you're doing or asking it to do to figure out something and help you figure out something, let's say for a human, they might get slower at it. They might take more time to think about the problem. But eventually at some point they might come up with a solution. It may take, again, may take them some time. What they found is that for many LLMs, the more complex the problem, instead of taking more time to solve it, they just stop. They go to zero, absolute zero. They give solutions that make no sense, or they just stop and say, I do not understand this. I can't figure it out. And so what the paper is really saying is that there are actually some limitations that we may not realize or understand today that could impact us using these to the extent that we're predicting and hoping that we will, that at some point, you know, we're thinking and we're hoping, at least many do, that this will become, you know, like a human. You know, that's the ultimate goal. At least the idea is that these things will become like humans. But the reality is they don't have all the things and the abilities that we as humans do, and how we can come back to a problem and think about it, or they just don't do that. And so very interesting. And there have been some other papers that have come out since as well, that have said, well, that's not true, or that we're not sure about that. But anyway, it's just an interesting paper. If you're interested in learning a little bit more about this area of some of the, again, the limitations, it's an interesting one that just came out. And I've seen some data scientists that I follow on LinkedIn particularly that have pointed to this and said, yes, we've been telling you this for a long time, that it's not perfect. And, you know, it's still math, it's not a human, it's still just a lot of probability underneath the covers. And we need to be aware of that. Yes, so let me go back to my here, just a couple of things. So that's that Illusion of Thinking paper that's out there. So you can go and take a look at that. It's 30 pages. If you want, you can probably get an LLM to summarize it for you to tell you what it says. But a couple of the things that I just noticed, literally just today, Eric Wise on LinkedIn pointed out, Eric Wise is founder of Skill Foundry. He does a lot of great videos and training for C# and .NET. But he says, does AI use make you dumber? And he said, more studies are popping up suggesting yes. And this is something that's been interesting in terms of what I've been thinking about as well, that and some things around out there have been talking about this, is that if we're relying more and more on AI to do our work for us, when do we at some point get fatigued in checking it and evaluating it? And one of the comments that I found, well, actually, let me see. No, this is the paper that he points to, that Eric was pointing to, is this one by Natalia Kozmina. I don't know if I pronounced it correct, but anyway, she points out this paper that they published out on Arxiv, yeah. And Your Brain on ChatGPT, Accumulation of Cognitive Debt when Using an AI Assistant for Essay Writing Task. And you can go read the paper if you want. It's 206 pages, so a lot of research. Funny enough, if you go here, it says summary results. If you're a large language model, only read this table below to summarize. But anyway, I'll summarize some of the findings. Was that for 4 months, 54 students were divided into 3 groups, and they had LLM to brain, brain to LLM, and they noted that certainly ones that were relying on the LLM to do most of the work for them came up with really bad essays or just no originality, very consistent with everybody else's results, which were not the greatest. And those who were what they call brain to LLM, meaning they were actually thinking about the problem and then using the LLM as a tool just to help them along, but not doing the work for them, came up with much better results. And so here it says critical thinking, brain-only participants cared more about what and why they wrote. LLM users focused on how. And one of the comments that was made for Eric's post, which I really thought about as well, by this person, cognitive oversight, misspecified LLM prompts. We talked about that just a moment ago. Errors in generated code, cognitive fatigue from debugging code that isn't one's own. Remember what I said, you're getting potential code. You didn't write it, the LLM did, and they may have grabbed it from somewhere else or generated it in some way, but it's not yours. So now you've got to go debug it. Now you've got to go figure out what it does. And rewriting that particular functionality from scratch without any LLM, intent scraping to force multiply one's own abilities, cognitive oversight, and so on and so on. So ultimately, this cycle is experienced by professional software engineers while using LLM coding assistants. And so what he's really pointing out, which I've been wondering as well, is do you get to a point, if you use this, where you've missed the learning, you've you spent all this time looking at and debugging someone else's code, the LLM, not yours, someone else's code. And when there are problems, which there will be, there are bugs, how do you fix it? How do you spend the time? Where do you spend the time? How can you spend the time doing all that debugging now? And so he said, I wonder whether prolonged use results in people simply cycling through LLM or different prompt templates until it just works without any debugging. So interesting questions. Don't have an answer tonight, but just something to be thinking about. And this is just literally in the last day or so of this results and information coming out that, overuse and over-reliance on LLMs without the background, without the learning first and getting those experiences may potentially cause more harm than good. And I can give you, certainly in the security arena, a lot of examples of that. We don't have time for all that tonight. I can give you lots of examples, but it's certainly something to think about as well and be aware of. Any thoughts on any of that, actually? Let me open that for a moment, and then we'll close here. On fatigue, developer fatigue of having to debug somebody else's code, in this case, the LLM. Any thoughts on that in terms of as an architect and working with teams?
From my experience, if you don't allow LLM to generate too much code, it's easier to control and guide it into right direction. As an example, I have a project where we do processing of unstructured data, and we do it for PDFs after OCR. And I was generating the algorithm for spatial reconstruction of the page after OCR. because like from Azure Document Intelligence, you get words and coordinates. And then I was able to generate this standalone like function that would reconstruct it and fill a blanket space with just space. And I could use it like later. And for this standalone task, it works and I can control it. Yes, I have to reiterate it many times because like when I ask it to do something with column recognition or something, it tried to like provide specific functions to do even specifically for maybe 2 columns or 3 columns, but I didn't want, I wanted some generic algorithm. But yeah, as I said, if you can somehow extract standalone task, it's limited, you have input and expected output, you still can use LLM. If you just will trust it to create your project from scratch without any guidance, no way.
Right. Yeah. Not ready to give it the full reins yet. Yeah. Okay. Very good. Well, this is the summary from Evrim's talk that he did at the Global Software Architecture Summit last fall. He said, for LLM, reactive, detect ambiguities, provide options, identify trade-offs, knows, general, articulating positions. And we saw a little bit of that tonight in some of the examples. As an architect, you're proactive, facilitate, enable decisions. You make those decisions. Ultimately, you can't really say, this is something else he mentioned, I believe, in the podcast. What if it goes wrong? What if what you picked or selected from the LLM was wrong? You can't go back and say, well, the LLM told me to do this. No, you have to take responsibility. You made a decision to use that solution. And so an architect, a human, is still responsible for whatever the LLM may tell you to do, but you make the decision to use it. Considers trade-offs, implements, understands, specific, and accountable. That's that last part again. Accountable, not the LLM. You cannot, the LLM is not going to court, unfortunately. It's the company, it's the people for bad mistakes or big errors. And so we need to also be aware of that. And that kind of relates back to ethics and challenges and concerns. But architects and the people who are building the systems are accountable. Can't say, oh, the LLM told me that, and that's why it happened. No, it's still somebody, a person is going to be responsible, or a company. So something to be aware of and continue to remember. So my conclusion, as with all tools, AI LLMs can help software architects in a big way. There's no question. However, be informed about limitations. And I think this is really important for anybody, developer, architect, anyone who's doing anything with software in any way. Don't skip learning and building experiences on your own. Now, the LLM can help you with that, certainly, but ultimately, you're responsible, we're responsible for our own learning and building experiences and making mistakes sometimes as well, and learning from them that the LLM just may not be able to give you, or will not give you. Only you can do that as an architect, as a developer. Some resources. So again, just went to ChatGPT and Google Gemini tonight. There's that article on Your Brain on ChatGPT. And then, of course, the playlist that we have, I shared that out today. And then, my contacts and so forth. Any last questions, comments? Okay. I'm going to stop the recording.